We are the Agitation Squad, sponsored by Cameron, and they challenged us to create a device that could harvest energy from human movement. So we decided to create a shoe device that would do just that.
To make this shoe generate power, we needed to really find which way the most energy was wasted and had most potential for gathering. So we really decided the heel strike, it was held by gravity, so we could use that without really any added effort on the wearer to generate the power. Because they're going to be putting that force into the ground anyways, and it's usually just absorbed by the foam of a shoe. And we decided rather than let that foam absorb it and spring back, we could drive some gears and drive a generator.
Our sponsor is actually developing an artificial heart for a human, and they wanted a power source that would be reliable and always available. So something like this would be great because this powers a battery pack while you're walking, and then you will always have a source of power that's reliable and always available for your medical device which you need to live. For this, at this stage, this could be used to power smaller portable electronics such as a cell phone, but in the future, a better device, more efficient, would hopefully be able to power medical devices such as smaller ones like a pacemaker or even an artificial heart.
What our device essentially is made up of is a lever arm that is on one-way roller clutches, so it only works in one direction. And this lever arm transmits, the vertical motion of the heel strike through the gearbox horizontally through helical gears. And as you can see, the gearbox, it's about a gear reduction of 61:1. So we're transmitting the high torque of a heel strike and converting it into high-speed rotation, which then leads into a generator, as can be seen on this shoe. Here, what this will be showing is that as it runs, as you step, each step will produce a peak in power, as you can see on the graph. And then that will supply the electrical components, and then each of these peaks will level out so that we could supply a constant level of power to a device.
Our goal with this was just to prove that we could make a device that would produce power. So that was really the main thing we considered. So things like size and weight and its effect on the user were kind of second. In the future, if another team picks this up, we would recommend them to figure out how to make it smaller, make it lighter. There's a lot of excess material in this one that can be removed. The pieces can be made smaller, and that's kind of our hope for the future for this device.